Alright, so this is one of the hardest questions in Maths A level I've ever seen. And it deals with derivatives and parametric equations. So let's begin. So the first part says convert the parametric equation x equals sine 2 sine t and y equals 3 sine 2t into a Cartesian equation. Well, the first thing I would do over here is square the y, because the question wants in terms of y squared equals k squared 4 minus x squared in brackets. So I would square the y and get 9 sine squared 2t. And then I would notice that sine 2t is a double angle formula. You can use the double angle formula to simplify sine 2t, and that would just equal 9 2 sine t cos t squared. Alright, and then you could simplify that further, which becomes 9 4 sine squared t cos squared t. And since you know cos squared t equals 1 minus sine squared t, you could write that as 9 4 sine squared t 1 minus sine squared t. Alright, so simplify that further and you get 9 4 sine squared t minus 4 sine to the power of 4t. Alright, and now you'd notice that the x has a t in it. And since you want a sine squared, you could square the x, or even x to the power of 4, and simplify this to get in terms of x. So let's do that. X squared equals 4 sine squared t. And there you go, 4 sine squared t, you can plug that in later. But let's try to find the x to the power of 4 part here. So x to the power of 4 equals 2 to the power of 4 times sine to the power of 4t, which is equal to 16 sine to the power of 4t. And since we want 4 sine to the power of 4t, you could just say x to the power of 4 over 4, so divide both sides by 4, equals 4 sine to the power of 4t. Alright, and then we just plug that in, so that equals 9 x squared minus x to the power of 4 over 4. Then we expand, we get y squared equals 9x squared minus 9 over 4 x to the power of 4. And then we can factorize this and get 9 over 4 x squared over 4 minus x to the x squared. And that's it for part A. Now part B is much harder. That's the harder part of this question. But yeah, let's begin. So part B says there's a circle C2 that touches C1 at 4 distinct points as shown in figure 5, and you want to find the radius of this circle so that it touches only the 4 points at the outer edges. So let me just draw that real quick. That's a really bad drawing, but bear with me. So we have something like this and a circle around it. And we've given that it touches at 4 points on C1. And we want to find the radius of the circle. Well, first thing, we know that the circle has a center at O, which is the origin. So we can say C2, the circle, equals, not equals, but C2 is x squared plus y squared equals r squared. R squared is the radius of the circle. And since we know y squared is this, that's why at the intersections it would be x squared plus 9 over 4x squared 4 minus x squared equals r squared. So we just plugged in this for y squared over here. Alright, so let's simplify that. We get 9x squared minus 9 over 4 x to the power of 4 plus x squared equals r squared, which is 10x squared minus 9 over 4 x to the power of 4 plus, equals r squared. Now, you need to notice that at this point, the bigger circle, C2, C1, C2 touches the points like a tangent, as a tangent would. So if I zoom in into this part over here, that's C1, that's part of C1, and then C2 comes around and touches at exactly one point on that part of the curve of C1. So that means that at this point, C2 touches C1 only once, instead of, let's say, it going through twice, because that would be 2 points each, so that would be 2 points over here, 2 points over here, that would equal 8 points in total of intersection. So you could see that this also looks like a quadratic. If you shift everything to the left side, that become 10x squared minus 9 over 4 x to the power of 4 minus r squared equals 0. And since we know it touches only once at this point, we could use that b squared minus 4ac of this equation would equal 0, this quadratic. Because if it was less than 0, that means it would touch more than once, or more than 4 points. And if it was greater than 0, that means it would not touch at all. So it would go something like that, and not touch the C1 at all. Alright, so now we just plug in the values. B over here is 10, so 10 squared minus 4a. A is the negative 9 over 4. By the way, it's a quadratic because you could switch the x squared for, let's say, y, and that would become 10y. But by the way, you don't have to use y. You could use u, for example, or anything. It's just a different constant we're replacing x squared with. So 10y minus 9 over 4 y squared minus r squared equals 0, and that's a quadratic. So yeah, 4a, and then a would be minus 9 over 4, because that's the coefficient for y squared, or x to the power of 4. So you put that in 9 over 4, and c would be minus r squared equals 0. So you simplify this and you get 100 minus 9r squared equals 0. Shift the 9r squared to the right side, you get 100 equals 9r squared, and then you simplify further, you get r equals 100 over 9 square root, plus or minus, but since the radius is not going to be negative, we use a positive, and this is equal to 10 over 3. And that's your final answer. However, the mark scheme uses a different approach for this question, and I'll use Desmos to explain this method. So I've got the graphs of C2 and C1 over here, and as you can see, the R is the radius of the circle. So if I increase it, the radius of C1 increases, and so forth. And these are the points of intersection at radius 2.8, for example. And as you can see, at this point of intersection, the x value is 1.008. And if I increase the radius, the x coordinate of the intersection also increases. So it's 1.12 now. And if I keep increasing the radius, at this point, for example, you can see it's 1.38. But over here at 1.592 x value, the radius of the circle is the same. So at both x values 1.592 and 382, the radius is 3.3. And if I decrease the radius again, you can see again that at 1.7 and 1.743 and 1.186, the radius is 3.1. So the radius is greatest when the x value is whatever the x value is at that point of intersection. So let me just find that out real quick. 10 over 3, and that is 1.4907. By the way, when you're doing this question, you might think that at the point of intersection, the gradient of the C1 would be 0, but as you can see over here, it's not. At the point of gradient 0 for C1, it would be over here and not the intersection. Because as you know, it only touches at one point of C1, which means that the gradient of C2 and C1 must be the same. And the gradient of C2 cannot be 0 because the gradient of C2 is only 0 at this point and this point. Alright, so as I was explaining before, as the radius increases, the x value of the intersection also increases for this point. But you could also say the opposite. As the x value of this intersection increases, the radius of the circle also increases. And then at the point of intersection, after that, if you keep increasing the x value, the radius starts decreasing, because then the x value, for example, over here is 1.743, but the radius is only 3.1. But at 3.333, at 10 over 3, the x value was in between 1.592 and 1.382. So if you think about this, you could realize that the change of the radius over the change of x is 0. So it's at this point, at the point of intersection, where it only intersects once, the radius is at a stationary point. The radius is not decreasing or increasing. Before it was, when the radius was smaller and you increase the x value, it's increasing, the radius is increasing. But after that point, it starts decreasing again. So that's a stationary point. dr over dx, r being the radius, is equal to 0 at that point. And I can show this on to you on a graph over here. If I put in the equation 10x squared minus 9 over 4 x to the power of 4 equals r squared ignore those lines for now, but let's make the r equal y for now and get rid of these other graphs. And I made it y so that this axis, the y-axis, is now the r. So for example, over here, r is equal to 3.33. As you know, that's the answer. And you can see this is a stationary point because it's increasing and decreasing. R is increasing and decreasing. The y value is r. So we want to find this point. That's what the mark scheme does. It finds dr. It finds when dr over dx is equal to 0, and finds the x value, and then plugs that into the equation to find r. Now for the working out to find r when dr over dx is 0, we start with the equation which was 10x squared minus 9 over 4 x to the power of 4 equals r squared. And then we differentiate this equation to get dr over dx. So we use implicit differentiation for r squared, which would become 2r dr over dx, and this part would just become 20x minus 9x cubed. Now we know dr over dx is 0 when r is at the maximum, so we can make this whole thing equal 0. 0 equals 20x minus 9x cubed. I can move 9x cubed to the other side and cancel out the x's, and we get 9x squared equals 20x. Sorry, 9x squared equals 20. And then we just rearrange for x. We get x equals root 20 over 9 plus or minus. Alright, and we plug this into the original equation to get r. So r squared equals 10x squared minus 9 over 4 x to the power of 4. We put in x, so we get r equals square root of 10 root 20 over 9 minus 9 over 4 root 20 over 9 to the power of 4. The signs don't matter because we're squaring it or we're doing it to the power of 4. So once you simplify this down, you get r equals 10 over 3, which we know is the answer.